Section 2.3, we're going to be working with piecewise functions. The essential question is, how can we evaluate piecewise functions and graph piecewise functions on the coordinate plane? All right, so let's define piecewise function. It's a function represented by subfunctions each corresponding to a specific domain. So over here in this example, the function has two pieces. It's defined to be 2x minus 1 when x is less than or equal to 1, and it's defined to be 3x plus 1 when x is greater than 1. So these would be the subfunctions, and these would be the specific domains associated with those functions. So we can see the graph when x is less than or equal to 1. So this is my x-axis. If x is less than or equal to 1, which it would help to, let's label this. So here's the y-axis, and here's the x-axis, and here's 1 on the x-axis. So when x is less than or equal to 1, it's going to be defined by 2x minus 1. So if you recall y equal mx plus b, your y-intercept would be negative 1 here, and then the slope would be 2, so up 2 over 1. So it would form this straight line. When x is greater than 1, so when you're over here on this side, it's defined differently. Now the y-intercept, so remember this is the y equal mx plus b that I'm working with here. So 1 is the y-intercept. So if it were to extend further, it would touch the y-axis there. And then the slope would be 3. So it would go 1, 2, 3, 1, 1, 2, 3, 1. Okay, so these are the two pieces of it that are actually given inside the domain that we have. So it's doing two different things depending on where the domain is. We're gonna be graphing some of these, but we're gonna start by just getting some practice with reading them and evaluating them. In example 1, we're gonna evaluate f of x for each of the following. F of x in this problem is defined to be x plus 2 if x is less than 2. It's defined to be 2x plus 1 if x is greater than or equal to 2. So in part A, remember when you're working with function notation, the number inside the parentheses is your x. So this means if x equals 0, what is y? Okay, so here x equals 0. So I have to come over here to decide where I need to be. If x equals 0, since 0 is less than 2, I need to use the top part. So I'm going to put 0 into x plus 2. I'm going to say 0 plus 2. So my answer is 2. In part B, f of 2. So this time, x equals 2. If x equals 2, I come over here. All right, so it's defined here when x is less than 2. I go to the bottom when x is greater than or equal to 2. Since x is equal to 2 in part B, I'm going to substitute 2 in for the x in the second equation. So I'm going to do 2 times 2 plus 1. So 4 plus 1 gives me 5. For part C, x equals 4. Okay, so x equals 4. 4 is greater than 2, so I need to go to the second equation this time and say 2 times 4 plus 1, and that's going to give me an answer of 9. Example 2. We're going to evaluate f of x for each of the following. Actually, I wrote this on a separate sheet of paper. It's a little hard to read on here. So for example 2, this is what we're doing. So our function is defined as 2x plus 8 when x is less than or equal to negative 2, x squared minus 3 if x is between negative 2 and 3, and it's the square root of x plus 3 if x is greater than 3. So in part A, x is negative 4. Negative 4 is less than negative 2, so that means for part A, we're going to use the top equation, or the top function. So we're going to say 2 times negative 4 plus 8. That's going to be negative 8 plus 8, or 0. For part B, x is equal to 6. 6 is greater than 3, so that tells me to use the bottom function. So I'm going to say square root of 6 plus 3. It's the square root of 9. Square root of 9 gives me 3. Part C, f of negative 2. So x equals negative 2. So that means I'm going to use the top equation. And I'm going to say 2 and put negative 2 in for x and plus 8. So negative 4 plus 8 gives me 4. Part D, x equals 0. So 0 is between negative 2 and 3. So 0 fits inside here. So I need to use the second function. And I'm going to say 0 squared minus 3 gives me an answer of negative 3. Okay, so now you're going to try the one below that. All right, you are going to, I want you to pause the video and do this problem and then check your answer.